Good morning, everyone. How's it going today? Welcome back to the channel, coming to you from France today. Sunny France. We're at 40 degrees today. We're melting. That is in Celsius. I'm not sure how much that is in Fahrenheit, but it's very, very high. Today we're going to be covering LlamaIndex, and the reason for that is that I was recently researching about this framework, and I figured that most of the content online about LlamaIndex is kind of out of date. So right now it's probably a very good time to create a longer series about all of LlamaIndex's capabilities and features that you can use in your projects and in your company, because now the company is at a much more stable and mature phase. So I figured that this series of tutorials is going to remain evergreen for a longer time. So yeah, in this first video of the series, we're going to be covering pretty much what is LlamaIndex, its particular take on context augmentation and drag. We're going to be covering that with a very cute diagram that we have right here. And then we're going to be going to the code so that you can just get your foot wet on the water so that you can start using this framework, which is pretty useful. So there you go. That's what we're going to do right now. So let's actually start talking about what is LlamaIndex. All right, so first of all, let's talk a little bit about what is LlamaIndex. Now, if you're here, I suppose that you already have a bit of an intuition or an idea of what is LlamaIndex, but in case you don't, and for the newcomers as well, I'm going to explain that really quick for you. A good way to think about this, if you have already a little bit of background in this, is that there is a lot of overlap between LlamaIndex and LangChain. They both allow you to create LLM applications. However, there are some differences that we will be covering during this series as well. LlamaIndex essentially is a framework or an ecosystem that allows you to create LLM applications such as chatbots, AI assistants, translation machines, or any other kind of applications that would require a language model in their services. And something that is very useful about them is that they also provide a lot of data loaders that allow you to enrich the knowledge of your language model with your own data. For example, your language model might not know anything about the contents of your email inbox or your company's database or your notes in Notion. Well, the idea is that a framework like LlamaIndex can allow you to enrich the knowledge of your language model with that information so that it can answer questions about your personal data or your company's data. All right, and they also allow you to create much more sophisticated programs such as AI agents, multi-agents, etc. Okay, now other than that, they also have some enterprise solutions such as LlamaCloud and LlamaParse, which are essentially the same thing that you would be able to code yourself, but taken care of by their own teams in San Francisco. In other words, what LlamaCloud can allow you to do is to help you ingest all of your personal data or all of the data of your company, put it in an index and use it with the language models that they have available so that you can create this kind of applications already within your company. So it's kind of a hosted version of the thing that you would be able to code yourself if you had a team of machine learning scientists and software engineers. And other than that, they also have this service called LlamaParse, which allows you to parse pretty much any kind of document and output a structured document from it. So for example, if you send a PowerPoint presentation to their API at LlamaParse, they will return to you a structured document with all of the contents of your PowerPoint presentation with a very easy to use API. So that is very, very useful. I also have a video about this. If you're interested, you can check that out. And there you go. So that is essentially the introduction of LlamaIndex, what their open source libraries do for you and what their enterprise solutions can do for you as well. So let's actually start by looking at what they and how they do this that I explain to you real quick right now. And we're going to do that explaining this with a very nice diagram. So here we have the diagram, and the idea right here is that I want to introduce you to what LlamaIndex does and how they deal with context augmentation. Now, if you have any experience with RAG or Retrieval-Augmented Generation, you may already understand a lot just by looking at this diagram. But the idea behind this introduction to LlamaIndex is that I wanted to go through the entire diagram again, highlighting the differences in how LlamaIndex deals with this, and also highlighting the main components of the LlamaIndex ecosystem. Okay, that's why some of these items are in different colors. Okay, so let's actually start by taking a look at the components and the high-level components of the LlamaIndex ecosystem. All right, so let's start off by talking about the first component of the LlamaIndex ecosystem, and that is data connectors. Okay. Now, remember that I told you that LlamaIndex is an ecosystem or a library that allows you to ingest your data in order to use it in your application. Now, that data is usually stored in unstructured or structured sources. What does this mean? That you may have your data in PDF files, in HTML files if they are websites, in CSV files, in Excel files, in Word documents, etc. And if you want to use them within your large language model application, you will need to take all of that data from all of these different formats and put them together in an uniform way. And that is essentially what the data connectors do. Now, data connectors are probably one of the most popular parts of the LlamaIndex ecosystem, because lately they have been putting a lot of effort into creating very sophisticated data connectors that allow you to ingest pretty much any kind of document you want in a much more smart way. That is actually what they do with LlamaHub. LlamaHub is essentially an API with a data connector that takes pretty much any kind of format to it and then gives out structured documents so that you can organize your data and you can use it with your language model applications. Okay. And they also have LlamaHub, which is an open source community where you can also contribute if you want. And essentially this community allows you to create any kind of the components in the LlamaIndex ecosystem and make them available to the community. But I feel that the most popular use of LlamaHub is also their data connector. So someone may develop an independent data connector for, say, Notion. So now you can use the Notion data connector to ingest your data from your Notion databases and use it in your LlamaIndex application. So that is data connectors, and so essentially they just allow you to take all of your unstructured or structured documents and put them together into a more organized way that you can use in your LLM application. Now, the next thing to consider is the output of your data connector, and that is the documents. So what is a document that we see right here? Now, as I told you before, you have these data connectors that will take all of your structured and unstructured files and will output documents from this data that you have right here. Now, you may be tempted to think that these documents are PDF documents or Word documents or things like that, but actually not at all. These documents actually are just programming objects with different properties, okay? Now, this document, for example, may come directly from your PDF. So your PDF, after being passed through your data connector, it will output this document right here. And this document is essentially just a programming object with one property titled text, or it may be titled content, depending on the framework. And that property will contain all of the text inside of this file. So it's essentially just a distillation of the contents of this data source. And then in another property under the same object, you will find the metadata. And this metadata will include the name of this source file, so that when you use this document in your application, you will know exactly from which file it came from. It may also contain the page range from where the information comes from in your original file. It may also contain the date at which your file was ingested in the data connector, etc. So essentially that is what a document is. It's just a structured representation of all of your data source. And this makes it much more easy to handle your data in this pipeline, okay? Now, the next thing that we have to consider is how these documents are then turned into nodes. So now let's talk about this concept right here of the node. And this is a very particular concept and very special one because it is very ingrained in how LlamaIndex works. And it does not do this by default when you try to do the same thing with LangChain, for example. So as you can see, I mean, remember that the whole idea of this presentation, of this diagram right here, is that we're trying to we're explaining how we would create a data processing pipeline that will take our unstructured and structured data sources and turn them into an index that you then will be able to query using a language model. So this index will contain your personal information, and then you will be able to use a language model to ask questions about your personal information that your model was not initially trained on. So what we have done so far is we have taken these unstructured data sources, passed them through a data connector, and put them into documents. What is happening after that is that the documents are split into different nodes. Now, what is one of these nodes? A node is essentially at the highest level just a chunk of your document, okay? So depending on the length of your document, it may be split into one or more or several nodes. And the idea is that the node retains the metadata from the document. So if this document contains the metadata that it came from this PDF, this node will also contain that metadata. But it is kind of a more granular piece of information, whereas the document contains a larger amount of information from the PDF. Now, there is one very important distinction between the node and the document, and is that not only is the node more granular, it is also interconnected with other nodes, creating sort of a network of knowledge, okay? So the idea right here is that your document may be split into several nodes, each node containing more granular information, and these nodes will be interconnected among themselves. And that the same thing between all of your documents from all of your data sources that were ingested. So that is essentially this step right here of creating the nodes, and that is a different step from the more simple implementation of this that we could have seen, for example, in the LangChain video that we did before. And LlamaIndex does this by default. So by default, LlamaIndex is going to be working with nodes, and it makes it more explicit that you're going to be manipulating them during your data ingestion process. Okay, so once that you have this network of knowledge in the nodes, we're going to go to the embeddings. And then finally, in this data processing pipeline, you have the embeddings of each one of your nodes. So each part of your network right here will going to be converted using an embeddings model into a numerical representation of itself, okay? So here there are several embeddings models to choose from. I mean, you can use OpenAIs, you can use many open source models as well. And the idea is that you're going to be embedding the contents from your node, creating a numerical representation of this. This numerical representation will also contain, in some way, will capture the meaning behind the contents of the information inside of the node. And then all of these numerical representations of all of the material that you had in your PDFs, HTML, and all of your files will be added together inside the index. And that is how we get to the index right here, which is another core component of LlamaIndex. And the idea is that the index is essentially just your vector database, which essentially is just a database that is going to contain all of your numerical representations of all of your nodes and all of your, and thus of all of your data. And this index is what you're going to be able to query in order to get the relevant information to any information that you're looking for, which in this case is going to be queried via your router and your retrievers. But let's take a look at what these are right now. But for now, just keep in mind that the index is a concept that you will be referred to several times during these mini-series and also inside of the LlamaIndex documentation. So that is what they mean when they say index. Now let's take a look at the retrieval process. And now we get to the part of the retrieval. And the retrieval is essentially when the client sends a query to your API or to your application, and you want to find the relevant documents that are relevant to this query. Now, the idea is that you have this thing that they call router right here, which is another core component of LlamaIndex. And the idea of this router is that it is going to decide which retriever it is going to use to get information from your index, okay? Now, each one of these retrievers is, of course, another component of LlamaIndex. And the idea is that each one of these retrievers may use a different strategy to query your index, okay? So the router will analyze your query, will then route it to the most appropriate retriever that will find the most relevant information, and then these retrievers are going to get back the relevant information from your index, which is the information from your data, from your custom data, and that is kind of the job of the router and the retrievals. And so we have our response synthesizer right here, which is another component from LlamaIndex, which will essentially just put together the documents that you got from your retrieval and then put them together with another prompt, send them to your language model, and then get a response with your enriched information. Okay? So that is essentially how LlamaIndex deals with a very simple and very regular RAG pipeline. And as you can see, it is very similar to what you would do in, for example, LangChain, but I wanted to go over this all over again, but highlighting the specificities of how LlamaIndex does it. So now you know what they are actually talking about when you see response synthesizer or router or index or data connector in the LlamaIndex documentation, or even in some other videos in this mini-series. Okay? Okay, so now we have successfully understood what are the components of LlamaIndex and what they actually do. We're actually going to start implementing them using a little bit of code right here, and you will see that it is actually very, very simple. So the first thing that you want to do is, of course, to install LlamaIndex, and to do that you have to run pip install LlamaIndex-uq, means upgrade and quiet, so that, as you can see, I don't have any output right here. And after that, we're going to initialize my API key from OpenAI. Now, LlamaIndex actually uses by default the language models from OpenAI, and to be more specific, it uses GPT 3.5 Turbo, which is a very inexpensive model, so you should be okay. But in case you don't want to use OpenAI, in one of the future videos in this mini-series, I'm going to be adding how to use this with local models too. So there you go. Now we have our OpenAI API key set up correctly. Now it is time to actually start implementing this pipeline that we saw right here. And LlamaIndex actually has this very famous and one of which they're very proud of, this 5-liner, which in 5 lines of code essentially just implements the entire pipeline that you have right here. So let's take a look at that. So the first thing that we're going to want to do is we're going to create a new folder called data, where we're going to store all of the documents that we're going to be ingesting, these documents that were right here. And in order to do that, actually, I'm going to be importing the Constitution of the USA, and that's all that I'm going to be adding right here. So I have the constitution.pdf, just a quick reference to an old video that I did about a year ago about RAG as well. So there you go. I am only going to be adding one single document right here, but just to be clear, you can add as many as you want inside of the data folder right here, and they're all going to be ingested as part of your pipeline. So there you go. So now this very famous 5-liner. So from LlamaIndex.core import vector store index and sample directory reader. So these are the two classes that we're going to be using. Vector store index is essentially the index that you saw right here. So in other words, your vector database. And we have sample directory reader, which is itself the ingestion object. The ingestion class that is going to allow you to ingest all of the data inside of your data folder right here. So there you go. The first line right here is going to be initializing all of our documents. So with this very simple line, what we're doing is we're generating the documents from our PDFs, and we're using as data connector this simple directory reader. And now the simple directory reader takes as parameter the folder where all of your documents are. And if you want to see, in case you're using Colab, if you want to see where you are and what documents you have access to right now, you can run ls like this, and then you can see that you're already in the working directory where your data folder is. So you can do cd data and then see what's inside of data, and then you can see that well, apparently that's not how you concatenate commands here, but that's okay. cd data and ls. Let's see, does that work better? Yeah, so there you have it. So we're inside content data, and then we have that constitution.pdf is inside of here. So just by passing data like this, or you could also do this like this, you're going to be passing it the data folder, and then we just run the load data method right there. Then the second line of this 5-liner is creating your index. So you're going to be generating your index from documents. So you're going to be creating this vector store index from the documents. This part is actually very similar to what you would find in another library like LangChain. And then you will be able to query this index by converting it into a query engine. And this thing right here is essentially just initializing the retrievers. In this case, we're only going to have one retriever, so we're not going to be using a router as we specified right here, but essentially that is what we're doing right now. And this query engine is already one that you can ask questions to. So let's query it using this line right here. So the response is going to be equal to query engine.query, and then you pass in your query. And then we can just print our response. And let's see what that is. So we're going to be asking about the first article of the Constitution of the USA. So we're importing from LlamaIndex all of this. And apparently there was a problem locating our data. Directory data does not exist. Apparently it does not exist. What do you mean? Oh, maybe we're still in data. So yeah, there we go. So we're back. Okay, so this actually persists in the terminal. So when I moved myself inside of data, I was running all of this inside of data. So now if we do this again, it should be okay. It ingested all the documents inside of data, and there we go. The first article is about the establishment of the legislative powers, etc. So there you go. I mean, that's the famous 5-liner from LlamaIndex. So now you have this very quick introduction of how to do this. Just a quick note that inside of data you can add pretty much any kind of file. Let me grab you a list right here. So here's the list of all of the files that you can add inside of your data folder. So it can be a CSV, Word file, EPUB, etc. And I mean, it is able to ingest all of these formats. As you may notice, LlamaIndex is becoming very, very good at unstructured data ingestion. So they even created this fabulous LlamaParse API for that. So yeah, I mean, they're very strong at this, and this is all done automatically. You don't have to load CSV loaders by hand, Jupyter Notebook loader by hand, and everything right here is going to be dealt with automatically. And you can of course get more detailed information about this if you go to the LlamaIndex documentation. Let me just do this like this. Going to paste this. Yeah, the LlamaIndex documentation, sample directory reader. And here you have all of the supported file types. And they also have a specific JSON loader. And of course they come from the Llama Hub, as we mentioned right here. Okay, so that was the famous 5-liner. Let me just show you how to make the data persistent as well. So if you want to make your data persistent, this index that you see right here is the one that you're going to be querying every single time that you're going to be asking your questions to your language model. And if we run this, again, we're going to be redefining our index. So every single time we're going to be ingesting all of the documents inside of data, inside of the data directory. And that's okay if you only have one document like this, but if you have several documents, you probably don't want to ingest them and to do all of this every single time you run your pipeline. So the idea right here is just, instead of storing this in memory, you're going to make it persistent. And in order to do that, they have this very quick, show you this, very quick script to show you how they do it. I mean, this comes of course directly from their documentation. So as you can see, they're importing os.path, essentially just to deal with the paths in your file system. Then from LlamaIndex core, they're importing again vector store index, simple directory index, but this time they're going to be importing storage context as well, and load index from storage as well, in case you already have created your storage context. And essentially this just makes your vector database persistent in your local machine. Here they're initializing the directory where their local storage is going to be stored. So here, as you might remember, we have the data directory right here. So this is going to be a directory added right underneath right here. And so here we essentially just test if the path exists for this one, and if it doesn't exist, we're going to be creating that persistent storage. So if storage does not exist, essentially means that we have not yet created our index. So we do that. So we do documents, we ingest the documents, we create our index with exactly the same line that we created it up here, and then we just store it for later in the persistent directory. And this is the function that you use in order to do that. So if you were doing this in, for example, your own application or your server, this is essentially the function that you would use to store this in your in your server. Okay. So index, which is this one, storage context, persist, and then you pass in the persist directory, which in this case is going to be storage. And then if the path already exists, which means that this one right here, this is going to be triggered, the else statement. And if the path already exists, it means that we have already ingested the documents and they have already been stored in our local storage. So what we do is essentially we just index them from storage. So we say storage context from defaults, we pass in the persistent directory, then the index, and then either way we can now query the index just like we did before. Okay, so that's very, very quick. explanation of what's actually going on and how to store this. Let's ask about the third article right now real quick. Here you can see, I mean, it saw that we have not yet a storage directory. And then the third article is about the terms of the president, vice president, etc. And if we go right here, you can see that the storage directory has been created. And inside of it is, of course, all of the necessary information for LlamaIndex to retrieve information from our personal data store, which is right here. Before we leave, actually, I wanted to show you something a little bit about the documents that we got ingested from here. And the idea is that we talked a lot about what the documents are in the pipeline right here, and I told you that they are programming objects, etc. But I didn't actually show you what they look like. So here we're going to be tapping into the documents that we ingested right here from the simple directory reader, which essentially converted our PDF into several documents. And we're going to tap into it first, but first of all, let's take a look at its length. So the length of the documents is 19, so we got 19 documents for our PDF file. And let's take a look at one of them to see how it is composed. So let's look at the fourth one. And as you can see, it's a document object. It has a property of ID, embeddings, which is a Boolean, and it has the metadata right here. And this property is very important because it tells you the file, the original file, where it came from. So you have the page label where the contents of this document comes from. You have the file name to say that it actually came from the constitution.pdf file. And you even have the complete file path to the file in your server or whatever you're persisting these files. Then you have the file type, the file size, the creation date of your file, the last modified date of your file. So yeah, I mean, this is, of course, you can see why this would be very important if you were implementing this functionality in your application. And then right here you have the property of text, which essentially contains all of the raw text of your file. Okay. Now in this case, it's not super pretty. It has a lot of line jumps like this, but it is good enough for a language model to interpret it. And there you go. So that is what the document is and what it looks like. So let me show you what the text itself looks like. So text, just going to print it. And there you go. So here's all of the text. So as you can see, we have the title, the section 7, and here you have all of the text from the section 7. Okay. All right. Now something else that I wanted to show you is how to do pretty much the same thing, but using their API on LlamaParse. Okay. So essentially, remember that right here we ingested the constitution.pdf file and we converted it essentially to raw text. Okay. That was pretty convenient, but the constitution.pdf file that I am using right here is actually a very simple file. It contains only text. In case you have a more complicated file, let's say that you have tables and images, etc., this regular simple directory reader is not going to do a great job with that. So what you can do instead of using this simple directory reader is using the LlamaParse service that LlamaIndex introduced a few months ago. And the idea is that you go to LlamaIndex.com, you click here on sign up so that you get access to their Llama Cloud platform, and you're going to be prompted to create an account if you don't already have one. And once you're in here, what you're going to want to do is you're going to want to first create an API key, of course, and once you have that, you're going to be able to ingest any number, to ingest up to 1,000 pages per day of complex documents. So the idea is that instead of using this simple directory reader, you're going to be sending your documents to their API, and they're going to be returning you the organized or even structured text that came from your unstructured file. So let me show you real quick how this works. I actually made a video about LlamaParse in the past, but it works pretty well for ingesting complicated formats. So I'm just going to copy the API key and I'm going to implement this right here with essentially the same 5-liner that I had right here. So what we're going to do is replace this line that takes all the documents, and we're going to replace it with this other line right here, which essentially just does the same thing, but instead of using the simple directory reader, we're going to be using LlamaParse. And in order to do that, you're going to have to do from LlamaParse. We're going to import LlamaParse, and there you go. But actually, in order to use this, you're going to have to add the API key that I showed you how to get just a moment ago. And in order to get the API key, you can just use this. You can just set your Llama Cloud API key environment variable. Actually, here is just a quick mistake. I'm just going to get the password right here. I'm going to copy and paste it from what I created up here at Llama Cloud. Now I have my API key set to the Llama Cloud API key variable. And now actually something else that I should probably do now that I am working in a Jupyter notebook, since Llama Cloud and LlamaParse in particular is an async first API. I'm gonna have to run this nest async IO just to emulate an async API. And there we go. So now that we have set our API key and our nest async IO, we should be able to call LlamaParse. And as you can see, we just specify the type of data that we want in return. In this case, we just want the text from our file, and then we load the data. And in order to load it, we're going to pass in the path to our file. So in this case, it was inside of data. And if I remember correctly, it's called constitution.pdf. So constitution.pdf. There you go. And now this should be able to work now. And as you can see, it is ingesting the documents, indexing, and then again we have the response from what is the first article about. The first article discusses the principles, etc. And as you may be able to see right here, my 1000 pages per day usage should be updated. Let's see. Well, it's not updated automatically apparently, but yeah, I mean, I just used I don't know, probably 19 pages off of my 1000 pages per day. And there you go. And let me show you what the documents from these ones, from this API looks like. As you can see, it's pretty much the same thing, but also, as you can see, the text is a little bit cleaner. So let's see, the text. Let me just use print to make it look better. There you go. So yeah, here we have it, that it's, I mean, the fourth document in this case starts at this paragraph right here with the section 7, and as you can see, it's a little bit cleaner. I mean, it doesn't really make a difference for this file in particular because this is a very easy file, the constitution.pdf, but yeah, I mean, you can use this for more complicated files as well. So there you go. That is just, I felt like I needed to include a quick introduction to LlamaParse in this LlamaIndex introduction video. So that's essentially how LlamaIndex works. It is, I mean, this is a much more simple implementation of what you would do probably in production, but of course this is an introductory video, and I just wanted to introduce you to a very quick RAG example in LlamaIndex. Okay, in the next videos in this series, we're going to be covering much more detailed and advanced topics of LlamaIndex, but please let me know if you have any questions, and if you're excited about more content about LlamaIndex, I'll be happy to be making more of it. So yeah, thank you very much for watching. If you have any questions, suggestions, or even corrections, please be sure to leave them in the comments below, and I will see you next time.